Hi, Eric here with 30 by 40 Design Workshop. Today we're continuing our look at the studio project, and I'll be discussing the concrete pour. Now there are 5 important considerations with a concrete slab that will act as a finished floor. They are, number 1, the installer. You want to use an experienced flatwork contractor. Pouring floors is fundamentally different than pouring foundation walls and footings. A good flatwork contractor has the proper tools and expertise to deliver a high-quality finished product. Using certified installers of any concrete admixtures or sealers is equally important, as improper application can result in blemished floors. Number 2, color. Concrete is composed of water, aggregate, sand, and cement. Its coloration comes primarily from the cement paste, which as the concrete is worked, rises to the surface. To change the tint, you can either color a batch at the mixing plant or do so after the fact with powders. Aesthetically, I prefer the natural color of concrete. But if you're looking for a color other than gray, you should work with a subcontractor experienced in colored concrete. Number 3, consistency. We want all the aggregate and the coloration between batches to be the same. Using a certified plant ensures we're getting the specified mix and that it's consistent. Now, of course, my concrete sub wants to ensure the best floor possible. And so, for our project, we've had to wait in line for concrete to become available from the plant we want to use. Not only is this a small project, but also it's been an amazingly busy late fall here in Maine. And so our small project put us lower on the priority list. Now, number 4, control joints. Concrete shrinks as it cures, and this always results in cracking. Control joints control where the cracking occurs. Because our slab is so small, it doesn't require them, but for larger floors, they're necessary and an important part of the finished aesthetic. They can either be tooled during finishing or saw cut later on. Number 5, reinforcing. Concrete is strong in compression, but very weak in tension. To overcome this, concrete needs to be modified to increase its tensile strength. Typically, we use steel to lend concrete the properties it lacks, but another option is to reinforce flatwork with microfibers. This is commonly called fiber-reinforced concrete. The fibers are mixed into the concrete before it's placed, and they're distributed evenly throughout the slab, acting in much the same way as the steel. However, they appear really furry on a finished slab. For the studio project, I specified heavy gauge welded wire mesh and wet set bars at the thickened perimeter for the reinforcing. Okay, so let's get into the actual forming and pouring of the concrete slab. I do apologize for the water spot at the center of the screen. It does go away as the video progresses, so please try and bear with it. We have our compacted sub base here of gravel. We have a thickened perimeter, and we're going to come back as the concrete sub arrives. They're going to insulate the subgrade with 2 inches of rigid insulation, and then they'll set the forms up on top of that. The rigid insulation basically contains the heat of the earth beneath the slab, and you'll note that it extends beyond the formwork here, and that is so that the frost doesn't penetrate beneath the slab and actually heave it. So they'll assemble their forms. We have a thickened perimeter, which acts to transfer the gravity loads from the building down to the ground. And they're setting up their forms here, and they're squaring them up. Now the center of the slab is not, it doesn't need to be as thick because it is just creating a finished floor slab area for us. It's actually 5 inches thick, and the perimeter is 2 feet thick. It doesn't need to be 5 inches thick because it's just a floor finish, but it prevents it from cracking. When we have a thickened haunch at the perimeter, you want to have a thicker center slab area to keep it from cracking. As they finish up setting up all the insulation here in their formwork, they'll square up the forms. And the last thing they'll do is lay out the vapor barrier here. And we have a thick vapor barrier to keep any moisture from the ground from migrating up into the slab. And there are specific concerns with that as you begin to pour the concrete, which I'll talk about a little bit later. So they've set that up, and the concrete sub, the flatwork sub, is going around calculating how much concrete he'll need. Now the day of the concrete pour arrives, and it's a cold morning. We have to, in the cold weather, we have to pour very early in the day. The first thing they're going to do as they arrive is they're going to set up the thermal breaks. Now, if you'll recall, the design has 2 slabs which will be on the exterior of the building that will be separated from the heated slab by a thermal break, and that is just a piece of rigid insulation. And you'll see them setting that up here. They're pinning it in place, and then they'll set the reinforcing for the concrete. We talked about using the wire mesh and then wet setting the bars. And shortly after this, the concrete truck arrives, and they'll begin pouring the thickened perimeter first. So they set all of the concrete at the edge there, they work it into the spaces, and they wet set the reinforcing bars at those areas. Then they start to work across the slab face here. and you'll see them spreading the concrete out, and the next truck comes. You can see how consistency is important. As we run through these batches, we want the entire slab to be consistent, and using a certified plant ensures that we get that consistency. Now they're basically tooling out they're screeding off the slab, creating the level surface, and they're doing a little bit of the handwork. They set the end slabs last, and as they set the end slabs, they add a little bit of air. Air entrainment keeps slabs that will be outside from cracking. Basically, the microscopic air bubbles give a place for any water that lands on them to expand into, rather than cracking the slab and inducing thermal stresses. It gives it a place to expand into. Now, we don't hand trowel those areas. We do a light broom finish on those end areas. If we were to hand trowel them, it would work all of the air out of it. And you'll note here that the concrete sub looks like he's just sort of waiting around, but actually he's not supposed to be touching the slab at all during this time. What's happening is the water in the concrete is hydrating the cement, and that is the chemical reaction. It's an exothermic reaction, so it's actually giving off a lot of heat here. But we don't want to work the bleed water. It's called bleed water. It's rising to the surface. You don't want to work that by hand into the face of the concrete. It substantially weakens the concrete if you do that. Now you'll see he's mechanically troweling the surface, and he waits until obviously the bleed water has dissipated before he starts doing that. This troweling process will be done 3 times with rough blades, so he's using rough blades here, and that's only on the center of the slab, and then he'll change out the blades for smooth blades. You can see he's just done that there. And the smooth blades really, as he begins to work it, start to really polish up the slab. It starts to hone the slab. It brings that cement paste to the surface and really makes it quite hard. Now we're using a 4,000 psi mix, and as he trowels this, it will become much denser at the surface and actually much harder. When you're pouring in cold weather, you really have to be careful about making sure it develops enough strength before it freezes. Here's an imprint that I used, placed as part of the design, something that we just stamped in there. It's imperfect. I like sort of the imperfections of it all. Now, as we get back to thinking about cold weather pouring, as he's working the concrete here, you'll see in a moment that it's starting to really go from a real dull look, as you can see in this image, and also this image shows our perimeter anchor bolts that we've set so we can attach our wood plates as we begin framing. He continues to work this, and as he works it each successive time, it becomes a little bit more glossy. Now, as we were talking about the cold weather pouring, we want to make sure the concrete develops at least 500 psi in strength before any freezing temperatures set in. And we do that in a couple of ways. First of all, we're using a water reducer to ensure that we have the optimal mix of water-cement ratio in the slab. And then we're also using hot water in the mix, so the concrete arrives a little bit warmer than normal, and it's developing a lot of strength here. You can see that it's beginning to build a little bit of gloss here as he works the slab. And I'm not too concerned about the inconsistencies on the face. We are actually putting a light honed finish as the final finish on the slab, and so the edge areas that you noted maybe were a little bit duller will get taken care of as we hone the slab. So they're getting ready to pull out here. They've done all of their finishing work. The next day arrives, and it's time to strip the forms. The concrete has made it through the night, definitely developed way more than 500 psi, and they come and quickly strip the forms off. And they do a bit of cleaning at the edge of the slab, and then the final step there is that they're going to apply a sealer to the 2 end slabs, and that actually happens a day or 2 later, so it's not apparent in this video. Now we're ready for backfilling, and you can see that we'll match the grade there, that where my truck is parked. We'll bring the grade back in, and we'll bring the power up, and all of this beautiful work will be hidden except for the finished slab indoors. So stay tuned for the next update as we start building on the concrete slab.